You bet your life on a few sparks. But out here, that's just a quick way to freeze in the dark. Hypothermia doesn't care about your feelings. It just does the math and shuts you down. Most people try throwing sparks directly at damp wasteland trash. It is a rookie mistake. Sparks burn at 3,000 degrees, but they only last a fraction of a second. Without perfectly dry tinder, that heat vanishes. You are left shivering in the dark. Again. You don't need luck. You need applied physics. You need to manufacture a carbon matrix. Char cloth catches the weakest microspark and holds it. It is your ultimate insurance policy. First, scavenge clothing, but never use synthetics. Melted polyester just glues to your cold fingers. Test it. Burn a single thread. If it melts into hard plastic, throw it away. You need 100% plant fiber, cotton or linen. They turn to pure carbon. Cut the clean fabric into small, uniform squares. Precision saves resources when everything is scarce. Next, find a metal container with a tight lid. An old mint tin works perfectly. Punch one small hole in the top. This is a pressure valve, not an oven. Pack the cotton squares loosely inside. If you cram them, the heat won't distribute evenly. Seal the lid tight. We are baking the material without oxygen. This is called pyrolysis. Place the sealed tin directly into the glowing core of an established hot coal bed. The heat breaks down the cellulose. The hole lets expanding combustible gases safely vent out. Without that vent hole, the tin becomes a low-yield pipe bomb. Physics requires an exit. Watch the smoke. Thick white smoke means moisture and volatile impurities are currently burning off. Do not touch it yet. Patience is the difference between survival and starting completely over. When the smoke stops, the reaction is done. The fabric is now pure, porous carbon. Pull the tin from the coals immediately. Use sticks. Do not melt your only gloves. Now comes the critical phase. If you open it hot, oxygen rushes in, instantly destroying it. The superheated carbon will flash ignite. Your hard work turns into useless white ash in seconds. Plug the vent hole with a small twig. Cut off all oxygen to the chamber. Let it cool completely. If you lack the discipline to wait, you will fail right here. Wait until the metal is dead cold to the touch. This takes about 20 full minutes. You can use this time to reflect on why you didn't prepare before the collapse. Open the cold tin. Inspect the results. You are looking for a specific structural chemical state. The cloth must be pitch black. It should feel velvety, not brittle, holding its tight weave. If it is brown, it needs more heat. If it crumbles to dust, you overcooked it. This perfect black square is now a highly receptive sponge for any stray thermal energy. Let's verify the chemistry. Gather a nest of dead, fibrous material from the surrounding concrete ruins. Place your char cloth in the center. Now, strike a dead lighter or a flint. One microscopic spark is all it takes. The carbon matrix traps the heat instantly, permanently. See that red glow? It will not go out. It spreads slowly, generating massive, concentrated heat. Fold the dry nest around the glowing ember. Give it oxygen. Blow steady and very long. The heat transfers from the carbon to the tinder. The smoke thickens as temperature rapidly rises. There is your flame. Routine, methodical, guaranteed. No panic required, just basic chemical engineering principles. Fire means boiled water, cooked food, and surviving the night. It is absolutely non-negotiable here. You just learned how to make fire out of garbage. What else don't you know?